negative points.
Have you ever seen Trailer Park Boys?
No. No. Once you're a grad student, then I let you call me by my first name. That's like I let that because I feel like that's just whatever.
What happens if we become friends on
by his
Facebook?
full name. I say Dr. Rico Capone when I introduce meet him all the way. Very formal.
Yeah. Doctor
Capone.
Professor.
It's
Yes.
Doctor, Mr. Doctor. It's strange, I know.
I tell when I tell my wife to do things. I mean, like suggest.
Yeah. Let's rephrase that.
I say doctor's orders. Doctor's orders. She hates that. She really hates that. No, she's not. She hates that too. Yeah. Also, we went to the same undergrad, and we were a little competitive about GPA, and I got .03 higher GPA than she did, and she's still a little bit upset about that. Also, it was just enough that I was magna cum laude, and she was just cum laude. And that also upsets her. It's really funny. I love it.
So around her, would she call you Magna Professor?
Yes. Yes.
I did not say that you use it in a fight, but I'm guessing that you could pull that one out and be like, Magna cum laude.
If we're trying to decide who's right here, I'm just saying. Yeah. Oh, man. Okay. We got to do this. So, we had introduced, you may recall, back over here, we had introduced probability, density, and mass functions. And we introduced an example of a probability mass function, the binomial distribution. And we were about to introduce, we did that example, that cool MATLAB example. So, yeah. Oh, and by the way, that one now comes with, not this version. If you look on the one online now, though, it comes with MATLAB code and sexy figure. So, I recommend checking that out. It's good times. So, it's essentially the stuff that we did in MATLAB, but I prettied it up a little bit, and I also generated 4 different distributions instead of just one. So, extra for loop, double for loop. It's great. Okay, Gaussian PDF. So we want an example of a probability density function so that we can use it in the coming lectures. The Gaussian or normal random variable x has PDF f of x equals 1 over sigma square root 2 pi times e to the, so exp is another way of writing e raised to the power of something. So e to the negative x minus mu squared divided by 2 sigma squared. So, although we're not quite ready to understand these quantities in detail, so what is sigma, what is mu, are the two quantities specifically. It can be shown that the parameters mu and sigma have the following meanings. Mu is the mean x, the mean of x, and sigma is the standard deviation of x, and sigma squared is the variance of x. So those are the meanings that we'll come to know about this Gaussian, but we want to introduce it now just to give us an idea. So I plotted this. We've actually seen it already once, but I plotted it for a mu of 0, and notice that it's centered about 0, symmetric about 0, and a sigma of 1 over square root 2, which gives me this distribution here. So this is used to model, we saw it modeling noise in an example I guess it was last lecture technically, but a couple times ago. And it was, remember, it was the Johnson-Nyquist noise we used, the noise generated from a resistor. It can be modeled with this Gaussian distribution. But there are other very many physical processes can be modeled with a Gaussian random variable. So I would say that it's almost. I mean, we call it the normal random variable. It's like kind of like the standard for random variables, like noise generating processes. If you don't know what it is, you're just like, well, it's Gaussian approximately, and we'll talk more about it. But there's actually going to be a lecture next week that's going to discuss more about the Gaussian PDF, because it's a pretty important PDF for us. Okay, so that is all I want. Oh, and you guys should be happy. So there are some professors who believe that grades should be distributed on a Gaussian probability density function, so-called bell curve. And there are professors and maybe even teachers in high schools and stuff like that who will curve their classes' grades to this. So you can essentially adjust people's grades so they fit on this curve. People don't like that.
Some people do it currently.
Mm-hmm.
We're not gonna talk about it.
It's actually, I mean, it's pretty common practice. I think there's no justification for it. There's absolutely no justification. Like, why do we believe that should emerge from the statistics? I mean, it does often emerge from taking a large number of samples in some random data set, but I really like to believe that people's performance in a course does not have to follow some probability distribution. So I don't use it, but yeah, so there are some professors who do like to use that. And it can mean that your grade can be adjusted down. So when I do curve a class, I do make it so that never happens. And what I typically do is I'll just adjust the mean around, typically up. And
Everybody did a little too well.
yeah, I move the mean up only, and then I will adjust the standard deviation a little bit, but only if your original score ends up being. I'll take whatever's higher, the original or the adjusted score. So I never give you guys. I've always felt like there's just something wrong about that, adjusting a score down. I should have made the class harder if that was the case. You feel cheated, and I don't like making people feel cheated. So. Okay, so that is the Gaussian PDF. Any questions on that before we go on to the next lecture?